There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and solarium, and bismuth, lithium, beryllium, and barium. Isn't that interesting? I hope you're all paying attention. There's going to be a short quiz later on. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury and molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radenzine, and zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
What?
Okay, I want to demonstrate how an iPad has polarized light, and I'm going to use sunglasses that are polarized. This sunglass cuts out vibrations that
But the computer also had polarized light.
Yeah, the computer does too. That's right.
Yeah, that's why it went black screen computer.
So, Charlie, will you?
And then whip, it's right back.
Will you lift this up so I can demonstrate it and talk about it?
Okay, I will lift this up so you can demonstrate it and talk about it.
I'll put it there. All right.
Now I will hold this.
Now the polarizers
you will hold this.
are all pointing in the same direction, so light is getting through. But if I cross them, you can see the light is blocked. And then when I uncross them, it's there again. Okay, so that demonstrates that, that this has polarized light.
When I was doing the computer, you see, and then when I went up to here, I went, whoa, like a mirror in front of a mirror. So then then I put this in front of you, and then I turned it. And then I turned it. So that it blocks the polarized light from the computer. See? It blocks the polarized light.
Is that it?
Okay.
Turn it on. Okay, so the light coming from this iPad is polarized, and the electric vector is pointing in one direction, and the magnetic vector is pointing in the other. I don't know which one's which, but one way or the other. And so this polarizer will block out the light because it only lets light through in one direction. And so when they're crossed, the electric vector, let's say, is going up from the light source, but it's blocked from the polarizer. Okay, so that's how it works. And of course, polarized light, a lot of light that's reflected is polarized, and so that's how polarized sunglasses work. Okay, thank you.
Tellurium, and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.